So for this question, it says let n be greater or equal to 1 and let a1, a2, all the way to an, and b1, b2, all the way to bn be real numbers. So, and verify the identity. So here we have two sequences of numbers, both the same length, and we have to verify this identity. That's the first part of this question. Second part of this question is concluding the Cauchy-Schwarz inequality with this identity. And the third is using the Cauchy-Schwarz inequality to prove the triangle inequality. So for this first part, we want to show this identity right here. And so let's first off try to substitute this value like right here, since it's just a smaller part of this right here. So let's basically simplify the term by following it right here. And we can easily simplify this term, the summation functions like right here, because summation of I equals 1, or summation of I is only dependent on the terms of a sub I, right? So b sub j is independent of a sub I right here. That's why I can simplify it right here. And we can get this term right here. The most simplified version is this right here. Let's plug this back into the main expression right here, down here. And we can basically just simplify this to equal what we desired, which is this right here as such right here. So for this part, it says conclude the Cauchy-Schwarz inequality based on what we just proved about identity. So we just proved this, right? These are two positive numbers right here that equal this, right? As listed right here. And so these two numbers are either between 0 or between this maximum number right here, right? And so if we take this number out right here, this number has to be less than or equal to. It cannot be greater. This is only false if this is greater, or if this expression over here is greater than this expression right here, right? But it's not, right? Because these two numbers, as we showed right here, are going to be equal to this. I mean, to remove this, this has to be less than or equal to this, as such. So for this part of the question, it says, then use the Cauchy-Schwarz inequality to prove the triangle inequality as such right there. So we can basically expand out what we have from right here, and we can just get this right here. I think it's important to note here, how can I make this step right here? And so basically know that a sub I times b sub I can be actually a negative number here. Take example, if you take a strictly positive sequence and a strictly negative sequence, this number will be negative right here, right? And so this number should be strictly greater because it would both like -1, and so this would be a positive number and a negative number. So for the case when a sub I times b sub I is going to be positive, right, this is going to be equal based on the absolute value function as such. And for a sub I and b sub I squared, these numbers are going to be strictly positive for both cases right here. So then this would always be true. And therefore I can put the equality as such. Next, I can continue to simplify. I can substitute the Cauchy-Schwarz inequality right here, and then factor it right here, simplify it, and I can get the answer as such.